Bismillahirrahmanirrahim. Hello everyone. In this channel, we will try to go over problems related to engineering, physics, and math. This is for folks who need help with doing their homework or test, or anyone who wants to learn something new. One of the easiest way for me to learn any problem is actually by practicing it and solving different problem related to that topic. And I hope you will find this very helpful. So I was thinking about, should I start with math as a basic, or should we just jump into doing physics problem? For me, it was always fun to actually go through the problem and learn math along the way, and this is what I'll try to do. So for today, I picked up a problem related to velocity vectors. So before we jump into the problem, I like to give a little bit of basics on vectors that is related to our problem. So we'll just go through some basic concept of vectors, and then we'll jump into the actual problem, and we'll go through and we'll solve the velocity vector problem. All right, so let's begin. So a vector. So basically, and I won't go into basic what is vector from A to Z. I'll just point out what is related to this problem that we have to solve. So let's see if we have a vector R, right? So now this is two-dimensional problem, so we'll just stay in two dimension for this case. So you have R as a vector and has two components basically, right? So you have x-axis, we'll call it positive x, and then you have y-axis, we'll call it positive y, and basically it has two components. Imagine if you're holding a flashlight, right, and then you'll see a shadow basically right here. So this is one component, the x-axis component, we'll call it Rx. And same here, when you put a flashlight here and turn it on, you'll see a shadow right here. And this is basically the y component of this vector R. Now, if you make it simple, if you look at this right here, this system right here, is nothing more than just a right triangle. So you have a right angle here, you have the y component, you have the x component here, and then you have the resultant here. All right, so this is the basics. So now let's do some some equations here to put this triangle into certain equations so we can solve it if we don't know any component of these vector. And then you have, I want like to add one more here, theta. You will find this very useful when we actually do the problem. So let's write the equation. So R, if we need to find R, how would we find it for a right triangle? It's the square root of both legs, right? Which is ry square plus rx, the resultant square. And this is how you find the vector itself. And then we can manipulate this number to find basically any other number if we know the other two, right? Now we have other equations that's related to theta, because a lot of times some theta is easily found, or is provided in the equation. So if we have that, what else can we do? So we have theta is equal tan ry rz rx, sorry, rx, right? That's one. And then if you remember If you remember, when you have the triangle, you can use sine theta that's equal opposite over the hypotenuse, right? And then you have cosine theta is actually base over hypotenuse. And then the last one is tan theta that's equal opposite over the base. So in this case, if you just use this, which is sine theta, so theta is here, the opposite side is ry, and the hypotenuse is r, right? And then cosine theta, the base is basically rx, so that's rx over r, right? And then this is very straightforward. Opposite of theta is ry over bases rx. So these are the basic vectors related items that we need to know to solve the problem. So what is the actual problem? So let's imagine that you have something that you want to launch, and it has it. Let's see here. So you launch something, and it has a velocity of 200 meter per second. Okay, and then let's make your axis. So this is your x-axis, and this is your y-axis. Okay, and you need one more information here. Let's say the angle that you launch this item, theta, is equal 20 degrees. Okay, so you need two information here that typically you'll be asked is what is your vertical component and what is your horizontal component. So, and let's see what is the difference, what are these, right? So if you look at the horizontal, imagine this is ground, right? So basically you want to know what is your ground speed, so which will be your horizontal component, right? And this will call it Vx, the horizontal component of it. Okay, so let's call it Vx. And the vertical component, which is how fast this thing is gaining altitude, right? So this will be Vy, and we'll call this Vy right here. So these are the two unknowns we have. Now let's jot down the knowns, okay? So for known, we have V that's equal 200 meters per second, okay? And then we have theta that's equal 20 degrees, all right? So these are the two key information that we need to solve the rest of the problem. So let's begin. So let's look at vertical component, right? So Vy, all right. So what we have to do to solve Vy. So remember when we discussed earlier using this triangle. So basically this is Vy in the equation, right? And we have this theta. Which equation do you think we can use to solve for Vy? You got it, because this is, we're going to use sine. Here sine theta is equal to opposite over hypotenuse. Why? Because we know the hypotenuse, we know the theta, so we only have one unknown that will be very easy to solve. All right, so let's write the equation down in here. So Vy, which is this, right? And we said sine of theta is equal opposite over hypotenuse, right? So we know sine theta, sine of 20, we know 20, right? It's 20 degrees. Opposite is Vy, that's what we're trying to figure out, right? But we know hypotenuse, that's 200 meters per second, okay? So now we just multiply each side by 200, and then we multiply this side by 200. So basically these gets cancelled out. So now the remaining is 200 sine 20 equal Vy. So now we have one equation here. We just have to solve it, and we'll do the next step. So let's write down the second equation. So this is for horizontal component, basically your ground speed. So we called it Vx. That's equal, or the equation that we're going to use. So let's go up and see what can we use to solve Vx. So in here, Vx is right here, right? This is the component we're trying to figure out. So what from here, which equations can we use to find the horizontal component? Can you guess? Yep, it's this cos equation, right? Using the cos formula. So let's come here and let's write it down. So let's see if we can capture this. So cos of theta is equal base time hypotenuse, right? So in this case, we know cos of theta is 20, base, which is actually Vx that we're trying to determine, and hypotenuse, which is V, which is 200 meter per second. So like what we did here, it's the same thing we're going to do it here. We're going to multiply each side by 200 times it by 200. I should have used more. I need more room. Times it by 200. So then we'll get 200 times cos of 20 equal Vx. So perfect. So now we have two equations that defines both x and y component, horizontal and vertical component of the problem. So now let's just solve it. You can use your computer, or if you have chart for sine and cosine, and you can get the numbers. So let's just solve this quickly here. So for your vertical component, which is Vy, is equal 200 times 0.342, right? And 0.342 is sine of 20, right? So if you want to do it by using a chart or using a calculator, sine of 20 is 0.342. It basically gives you 68.4 meter per second for your vertical component. Now for your horizontal component, let's solve this. So you have 200 times cos of 20, which is equal 0.9397, which if you multiply will give you 187.94 meter per second. So now let's see if something makes sense or not, right? So now you have Vx, which is basically right here, Vx, right? Which is 187.94 meter per second. And then you have Vy, that's equal 68.4 meters per second. All right. So my drawing does not do justice for 20 degrees. 20 degrees is a very acute angle, right? It's a very acute angle. And you can notice, since it's a very acute angle, most of the component is at x-axis. Hence, the Vx value is much higher, it's 187 compared to the y component, which is 68.4. So it does kind of make sense that if you have a acute angle like that, and as the number, this theta gets smaller and smaller, the value for your horizontal component will get bigger, bigger, and bigger, and eventually, when it becomes zero, it will be 200 meter per second, right? Because there's no component for your y-axis, and vice versa. As the theta gets bigger and bigger, right, your y component will get also larger as well, and your x component will start to shrink. Okay, I hope you had fun doing this problem. If you have any comment or question, please feel free to add your comment and I'll try to respond to you. Thank you. Hello once again. After I stopped recording, I realized I never showed you how to actually accurately calculate your answer if it's right or wrong. So we discussed theoretically, why it makes sense, but we actually never checked the number. So here's a quick check that you can do when you have this. Remember when we discussed a right triangle and this equation right here? So if you know all the component, it should add up, and this the resultant, your vector should be the square root of sum of the both components square. So the way you can do it is, let's write the equation here, and then we can do it together. So that's the y component and the x component, right? So in this case, we have vector v is equal square root of the y component square plus x component square, right? So in this case, let's solve this further. You get square root of 68.4 square plus 187.94 square. So here's the question for you, all of you. What did you get? Please include your answer in the comment section. Thank you. Bye bye.